So what we have today is the lesson 3A is the one that is assigned as homework. So lesson 3A is estimate irrational numbers is what we did this week. So I'm going to name this one the key so I can help you out a little bit. So it says study the example problem showing how to estimate the value of an irrational number, then solve problems 1 through 8. We always start looking at examples and then we model those problems. So for example, I have estimate the value of a square root of 6 to the nearest hundredth. Okay, so in this case, because the square root of 6 is between a square root of 4, which equals to 2, and a square root of 9, which equals to 3, the square root of 6 is between 2 and 3, but it's closer to 2 than to 3. Find the squares of 10 that are closer to 2 than to 3 in order to find which to 10 the square root of 6 is between. Remember what we did in class was I usually start with the perfect squares. So 1 times 1 is equals to 1. 2 times 2 is equals to 4. 3 times 3 is equals to 9. Okay, so that means square root of 6 is between these two values. Square root of 6, that means between 2 and 3. So those are the numbers that we are going to try a little bit. And we have, for example, 2.3 to the second power. Those numbers are estimates. Okay, and it says find the square that tends closer to 2 than to 3. So we're going to find numbers closer to 2. And remember what we did in class. If you multiply 2 times 3 times 2 times 3, so 3 times 3 is equals to 9. 3 times 2 is equals to 6. 2 times 3 equals to 6. 2 times 2 equals to 4. So we have 9. Then we have 6 plus 6 is 12. We have 1. Then 4 plus 1 is 5. How many decimal units are we moving? How many do you have? 1 here, 1 here. So we have 2. So 1, 2. So it's 5.29. And you have it here. That's where this value is coming from, 5.29. Then you have 2 to the fourth. 2.4 to the second power equals to 5.76. I'm not going to do it. We have an example here. And then I have 2.5 to the second power equals to 6.25. And in this one, because this is almost exactly halfway between 5.76 and 6.25, the square root of 6 must be almost exactly halfway between 2.4 and 2.5. So that one has to be between these 2 points. Now we can find which 200th square root of 6 is between. And in this case, we have between 2.44 square, 2.45 square. So we get these two, 5.9536 and 6.0025. So the square root of 6 is between 2.44 and 2.45, but it's closer to this value. Now, knowing all that example, remember it says estimate the value of a square root of 6. We are not going to get exact value. It's a closer, it's an estimate. Then problem number 1, mark a point at the approximate location of a square root of 6 to the 100th place. So we are going to do, we have 2.4, 2.41, 2, 3, 4, 2.45. So I'm going to do it around this value here, really close to this one. So here will be an approximation of a square root of 6 according to this information. Okay. Problem number 2. Check your answer by finding a square root of 6 using a calculator. What is the result on your screen? Remember, I have my calculator here. So I turn it on and I have 6 square root is 2.449487. I'm going to write those digits. So in this case, I have that square root of 6. And remember, this symbol is approximately equals to, it's not equal, it's an approximation to 0.44948 and 7 and so on. It keeps going, doesn't stop. Now they're asking me, find square root of 10 to the nearest hundred. Explain how you found your answer. In this case, remember that we need to write an explanation. We need to know what we are doing. Remember here in vocabulary words, irrational number is a number that cannot be expressed as the quotient of two integers. Quotient is a fraction. So you have A over B. You cannot put an irrational number as a fraction. So the decimal form never terminates or repeats. So for example, square root of 3 is an irrational number. Let's look at this one. So I have square root of 3, and square root 1.732050 and so on. So it doesn't repeat, it doesn't terminate, so it's an irrational number. So let's do a square root of 10. Remember what I do. 1 times 1 equals to 1. 2 times 2 equals to 4. 3 times 3 equals to 9. 4 times 4 equals to 16. So square root of 10 is between those two values. So it's between 3 and 4. Closer to 3. Why is closer to 3? Because I have 9 here. And this is 16. So 10 is closer to 9 than it is to 16. So a value is close to 3. We are going to be looking at values close to 3. So let's do number 3. I knew in this case, according to this information that I have here, I'm going to type. I knew it was between square root of 9 and square root of 16. Those are the values that I have here. Or between 3 and 4. This one. See, I circled this one. But closer to 3. Then, the next step that I took, then I found that it was between 3.1 and 3.2. How I found that one? By multiplication. You approximate those values by multiplication. Finally, I found that it was between 3.16 and 3.17, but closer to 3.16. And that's something that you can write. Remember, we follow this example and then we approximate those values by multiplication. Okay, so for example, really fast, 3.1 times 3.1. So 1 times 1 is 1, 1 times 3 is 3, 3 times 1 is 3, 3 times 3 is 9. Then 1, 6, 9.61. See, 9.61 is closer. So you're trying those numbers, so on, and you're going to find this value. So that's for number 3, page 25. Now we move to page 26. So solve. We're going to explain how a rational number and irrational number are different. Remember that a rational number is a number that repeats the decimal part or terminates, or you can make a fraction. And irrational doesn't have that characteristic. So in this case, a rational. I'm going to define irrational. A rational number can be written as the quotient of two integers. So I put integers there. And while an irrational number cannot. Okay, so that's something that you can explain. You can use your own words. In this case, I just decided that a irrational number can be written as the quotient of two integers, and while an irrational number cannot. So in this case, number 5. Describe how you will compare 3.6 and a square root of 12. Okay, so I'm going to type here what I think it will be a correct, not correct, but closer solution. So first, I will find the two integers that square root of 12 is between. I know if you do it, for example, 2 times 2 equals 4, 3 times 3 equals 9, 4 times 4 equals 16. So it's between the square root of 9 and the square root of 16. So it's between these two numbers. That means 3 and 4, but it's 12. Okay, so it's in this case a little closer to 3 than it is to 4. So in this case, continuing here, it is between square root of 9 and square root of 16, or between 3 and 4, but a little closer to 3. Okay, what else? We remember that we have a square root of 12, and then we have 3.6. Now we can say, then I will find two decimals. Remember, then I will find two decimals to the 10th. That means 2.1 or something closer, between 3 and 4, 3.1, 3.2, 3.3 to the 10th. That square root of 12 is between. Now, I found in this case, I tried 3.4 squared, and if you multiply those, is equals to 11.56. And I tried 3.5 squared, and this one will give you 12.25. So it's between 3.4 and 3.5. So square root of 12 is between 3.4 and 3.5, because 3.6 is greater than 3.5, and so on. So in this case, it's between those two numbers. So that will be your solution. You can type other solution. The way you solve it, you cannot type over there an example if you have. Number 6, I have, is 1.75 a reasonable estimate of the value of a square root of a? Explain your reasoning. Remember that we need to think what we're going to do. So in this case, I'm going to start with the square root of a. So I have 1 times 1 equals 1. 2 times 2 equals 4. 3 times 3 equals 9. So square root of a is between square root of 4 and square root of 9, between those two numbers, or between 2 and 3. But it's closer to 9, it's closer to 3 than it's closer to 2. So the question is 1.75 a reasonable estimate of the value of square root of a? Explain your reasoning. I'm going to say no. No here. Square root of a is between square root of 4 and square root of 9. See, I'm just typing what I just did mathematically here. Or between 2 and 3. See what I did here. Because I put because 1.75 is less than 2, comma, it is not reasonable estimate. Okay, 1.75 is not a reasonable estimate. So let's give it a try. So if you have 1.75 times 1.75 is equals to 3.06. So it is completely short of a number. Okay. Number 7. On a number line, will the square root of 20 be closer to 4.4 or 4.5? Explain your reasoning. Remember what we do, and here is when you're going to use, if you have is square root of 20. So I'm going to say 4 times 4 equals 16. 5 times 5 equals to 25. So where is 20? It's between the square root of 16 and square root of 25. So it's between these two numbers, but closer to which of these two? Okay, I'm going to say closer a little bit to 4.5 or 4.4. So let's do the following. Number 7 is closer to 4.5, and then you have 4.4 squared is equals to 19.36, and 4.5 squared is equals to 20.25, which is closer to 20 than 19.36. So in this case, 20.25 is closer. Here I put is closer to 20 than 19.36 is to 20. Okay, then it says look at the 2 points on the number line. Each number graph is the square root of a whole number that is not perfect square. Write the appropriate square root in each box. Explain how you found your answer. So I have 2 dots. Okay, so I need to figure out what's going on. How do I start? Looking at this number. If you have 2, what is this? You have a square root of 4. Square root of 4 is 2. So which one is this one? Square root of 9 is 3. This is 4. So that means square root of 16. And then you have this value here. So now we know we're going to think a little bit. Look at this one. How many spaces are this one? 1, 2, 3, 4. So that means each one is 0.25 or 1/4. Each one of those ones. So what can we do? Let me answer. So I knew that the first square root was between 4 and 9, but it's closer to 9. It's between 4 and 9, but it's closer to 9. So which one I'm going to say is there? Okay, let me type here. I knew that the first square root it was between square root of 4 and square root of 9, and just a little more than 2.5. 2.75. You count 2, 2.25, 2.50, 2.75. So it's just a little bit more than 2.75, okay? Because everyone is 0.25, 2.25, 2.5, 2.75. So it's a little bit more than 2.75. A little bit more than 2.75. So I square 2.75. So I multiplied 2.75 two times and found that it was 7.5625. Okay, so it's closer to, I'm going to say 8. The closest whole number, in this case, the closest whole number is 8. So I label that point square root of 8. So I'm going to make this one square root of 8, okay? And then the next one, look at this one. You have 4, then these points. I found my other answer the same way. So I'm not going to type another solution, just the same way. This is 16, so I'm going to say this one is the square root of 20. So I found the other answer. I found my other answer the same way. Okay, what is the important word? Rational number is a number that can be expressed as the quotient, division of two integers. For example, 2.5 is 25 over 10. 0.8333 is equals to 5 over 6. See, it's repeating term, repeating and terminating, or the quotient of two whole numbers or two integers so far. So that's 26. Let's move to page 27. Let's be careful with page 27 because you need to read this problem. So we are going to reason and we are going to write. So what we have, study the example problem. Underline two parts that you think make a particularly good answer and helpful example. So for example, we have tell whether the following numbers are irrational or irrational and explain how you know. So for example, just looking at the first one, 1/9. That's the quotient of two integers. So it's a rational number, but we need to prove it. Then I have a square root of 1.44. Now that one, I'm not sure, so I need to follow some steps here. Write a decimal approximation for each number and place it on the number line. So we're going to place it on the number line. So show your work. So we are going to, in this case, use a decimal approximation, number line, or words to explain the answer. So this one is already solved for you. So possible answer, 1/9 is a rational number because it's the quotient of two integers. And here's the division, okay? And it's a repeating term. And because it's the quotient of two integers, when I divide 1 by 9, I get a repeating decimal. Then the square root of 1.44 is also a rational number. Remember, this is an example that we need to study. I know that 1.44 is between a square root of 1 and a square root of 4, or 1 and 2, but it's closer to 1. Then I can find 2/10 that 1.44 square root is between. So in this case, they multiply these two values. Because 1.2 squared is equals to 1.44, I know that a square root of 1.44 must be 1.2, which is a rational number. And then they mark the positions in the number line. So you're going to study that case, and what happens? We turn around the page, and we have our own example that we need to show the work, and we need to type a solution. So for example, solve the problem, use what you learned from the model. So tell whether the following numbers are rational or irrational and explain how you know. So you have a square root of 2 over 8 and a square root of 2.56. Write a decimal approximation for each number and place it on the number line. So show your work. Remember here, did you identify whether the numbers are rational or irrational? Include a decimal approximation, include a number line, use word to explain. Those are the topics that we need to cover. So in this case, look at this one. I'm going to do this one. Square root of 2 over a. So if you simplify, 2 is divisible by 2, a is divisible by 2, so you have a square root of 1 over 4. Okay, what is the square root of 1? Is 1. What is the square root of 4? 2. So it's 1/2. So out of, I would say out of the bat, I know that this one is a rational number because it's the division of two integers. It's 1/2. And that one is more difficult. So here, let's do this one. For the first one, square root of 2 over a is a rational number. I know that. Square root of 2 over a is equals to the square root of 1 over 4. See the steps that I took over there? And I'm going to follow a different step here. That 1/4 is equals to 1/2 times 1/2 equals to 1/2 squared. So I'm using the second power to eliminate the square root. This means square root of 1 over 4 is equals to square root of 1/2 to the second power equals to 1/2. So this square cancel the radical, so you have 1/2, which is a rational number. A little bit harder is the second one. So I have square root of 2.56 is also irrational. And let me type something here. So it's 2.56. So I'm going 1 times 1 equals 1. 2 times 2 equals 4. So this number is between a square root of 1 and a square root of 4, or between 1 and 2. But it's 2.56. So it's closer to 2 than it's closer to 1. So let's try not numbers closer to 1, but like 1.5, 1.6, 1.7. So let's see how this works. So it's also irrational. I know that. Square root of 2.56 is between square root of 1 and square root of 4, or 1 and 2. But it's closer. To 2 by a little bit. Then I can find 2/10 that square root of 2.56 is between. So in this case, I'm going to use 1.5 to the second power, and if you multiply that one, it will be 1.5 times 1.5 equals to 2.25, and 1.6 squared is equals to 2.56. Now in this case, see, 2.56 is 1.6 to the second power is the same as this one. So in this case, I'm ready to close because 1.6 squared is equals to 2.56. I know that square root of 2.56 must be 1.6, which is irrational. Is a rational number, and that will be your solution. Now we need to mark those solutions in the numerical line. Where are we going to put it? Remember, this is page 28 in your book, and we're going to put it in a number line that we already have there. So in this case, if you draw a line, I'm going to have 0, 0.25, 0.5, then a 0.75. Remember that it's this one, so I'm following these numbers. So I'm going to have here 0.75, 1, then I have 1.25, then I have 1.5, then 1.75. So in this case, 1/2 is 0.5. So in this point is the square root of 2/8. And square root of 2.56 is 1.6, so it's here. Square root of 2.56. And let me prove you that square root. So if you have 2.56, square root is 1.6. And that's your solution. And that's the homework that you have for this day. If you have any question, please email me. I will be glad to help you. And I hope you have a wonderful weekend.